show and tell about the groundwater treatment system at the Hamilton Labree Superfund Site. My name is Andrea Lindsay. I'm an EPA Community Involvement Coordinator. We have some very interesting presentations for you today, and we will be taking your questions too. We will hear from our EPA Project Manager, Linda Meyer, followed by Michael Kraus, who represents the contractor URS Group. Your phone lines are muted. And for those of you online, you're welcome to use the chat box to share your thoughts or to ask questions. For those of you who are on the phone line only, welcome. I realize you will not be able to see the presentations live or participate in the polls. We will answer as many questions as we can after the presentations, both from the chat box and from the phone. We'll do the best we can on those questions. You can type them in at any time. And also, we will post the recording of this meeting for people to access later on EPA's Hamilton Labree website. So now let's just take a quick look at those poll results. You can look in the chat box to find those. Okay, great. It looks like we have a solid mix of people from different backgrounds. Thank you all for being here today. So while we wait for everyone to get settled in, let's just do a quick second poll. We'll go quickly through this one. The poll is, how did you hear about this virtual event? And you can click one best answer. And we'll give just a few seconds for you to see the poll and to make your selections. This will give folks time who are still joining us. Okay. Great. Okay. So it looks like people have heard about this event in some different ways. That's great. We do want to be sure that we're doing a good job communicating with people who might be interested in the cleanup. And now I am very happy to turn it over to our EPA project manager, Linda Meyer. Linda?
Good afternoon. I'm Linda Meyer, EPA project manager for this cleanup. Before I get started providing a brief background of the site, I want to take a minute to thank many people who've helped on this project, including those involved in the planning prior to my involvement, as well as those who've helped pull this off during a pandemic, including our partners at the state, county, and city, as well as the contractors and businesses who've provided materials and services. I also want to thank those of you who've lived in the area and have been impacted by the traffic delays. Thank you for following the speed limits and road restrictions. Following those keeps our hardworking contractors safe. And finally, a big thank you to B&M Logging for providing space to locate our treatment and support system. They've been very helpful. So the first slide, Dominic. The Hamilton Labree Roads site is located 2 miles south of Chehalis, east of Hamilton Road and west of I-5. In the past, a chemical called PCE was spilled or dumped in Berwick Creek in this area. The PCE contaminated the groundwater. The groundwater flows in the direction of the arrow. The dots show where residential wells are located. To protect public health, these properties have been connected to the public water system, and these wells are no longer used for drinking water. And next slide. PCE is a chemical used in dry cleaning, metal degreasing, and other industrial processes. It's called perchloroethylene, or tetrachloroethane. In the 1990s, it was discovered in some local wells above safe drinking water levels. The source of the contamination was found near Hamilton Road near Berwick Creek, and that's what we're cleaning up now. Also back in the 1990s, EPA and the Washington Department of Ecology excavated 70 buried drums from under a building in the livestock market area. Next slide. As I noted, the immediate risks to people have already been addressed. To address the longer term risks, EPA collected data and conducted studies to look at the risks to people who use water or are exposed to contamination in the impacted area. This analysis led EPA to take this cleanup action to protect public health. Our ongoing work will inform future cleanups. Next slide. Cleanup has started in the Berwick Creek area and includes rerouting the creek and removing the contaminated sediments from the bottom of the creek while temporarily relocating the channel. This work was completed in November. Right now, we're heating the soils to vaporize the PCE, and these gases are captured and treated. Once the thermal work is complete, which we expect to be in about 4 weeks, we'll use bioremediation, which entails adding safe microbes to the groundwater to enhance the natural breakdown of contaminants. Then finally, we'll be deconstructing the system and restoring the creek channel. So today we'll give you an inside look into the cleanup and treatment operations. Andy, back to you.
Thank you, Linda. So I apologize. We had a few issues with the poll, and I'm wondering if Dominic, if you would be able to try running that poll one more time on the screen. We're hearing from folks in the chat that it didn't work properly for many. Okay.
Both polls are still open on my end. It doesn't appear I can close them and reopen them if people would like.
Okay. So maybe the thing to do here, Dominic, for those of you who were unable to see the poll on your screen, if you scroll back through the chat, though they should be available for you there. Here they come on the screen again. Thank you, Dominic. Okay. So you're welcome if you'd like to participate in the poll to click on the answers either in the chat or on your screen if they're showing up for you on the screen. And these are just giving us a little bit of information about how well we're doing in reaching people and what avenues are working well to get our messages out and make sure that people know about the work that we're doing in their community. So thank you for that. And Dominic, I appreciate you running that one more time. Okay, let's do one last poll here, Dominic, while we're on a roll with these things. The groundwater treatment system is visible from Hamilton Road and from I-5, and we've got a poll asking you whether or not you have seen it. So Dominic is putting that up on the screen now for those of you who are here joining us online, and you can check that either yes, you have seen, or no, you have not yet seen the groundwater treatment system. So you can go ahead and submit that answer, and we're seeing that, yeah, many of you have seen the groundwater treatment system. That's excellent. I'm glad to hear it. It's really an impressive site. So I think it's now time to move on to the heart of our show and tell event. Michael Kraus is here to give you an exciting window into the groundwater treatment system. And Michael represents our contractor, the URS Group. Michael, over to you.
All right. Thanks, Andy. Again, my name is Mike Kraus. I'm with URS or AECOM. We were hired by the Corps of Engineers to design, construct, and operate the remediation systems here at Hamilton Labree. And today we're going to talk a little bit about the ISDR system, get you a kind of a firsthand look at the equipment and materials that we have in place, and a little bit about how it's functioning. First, I'd like to kind of start out with an animation that briefly describes and shows you, what we're trying to accomplish subsurface, things we can't see walking around out in the treatment area. The volume on this animation is a little bit light, so you might want to turn up your volume on your computer if you have that opportunity. So Dominic, you want to start that?
Thermal treatment, called in situ thermal remediation, uses extreme heat to treat the contamination. Both electrical and steam heat will be injected underground to convert the PCE to a gas. The gas will be captured and treated. A heat barrier will help keep the creek cool.
All right. So hopefully everybody could hear that. And as part of our in situ thermal remediation system, we're applying two different types of energy to the subsurface in order to create the heat necessary to drive off the PCE contamination. One method we're using is electrical resistance heating. And with that technology, we actually force electrical current through the soil to generate the heat it takes to drive off the contaminants. Now, this particular technology works well in a clay soil that water doesn't pass through very readily. In our treatment zone, we have different depths where we're applying this electrical energy. One is a very shallow area where we have a clay layer that's from about 3 to 8 feet below ground surface. And then there's another clay layer deeper down about between 24 feet and 31 feet below the surface, where we're applying electrical energy. We're also, the second technology we're using is called steam enhanced extraction, where we force steam into the subsurface and have it migrate between the injection points. And this particular technology is used in more granular soils where the steam can readily pass through the material. Again, there's two different layers where we're applying the steam. One is between the two clay layers from about 8 to 24 feet. And the second layer is below the clay from about 31 to 47 feet. So as you can kind of tell, our treatment system is, not only spatially defined, but it's vertically defined in these different sandwiches, these different layers. Next slide, please. So once we get the soil heated up and we start driving off this PCE, we need to collect it. We need a way to extract it from the system. So we have two different ways of doing that. We have vapor extraction and we have groundwater extraction. So the vapors, as you saw in the animation, they will kind of migrate up toward the top. And so we have, as you saw at the end of that animation, there's a concrete cap over the shallow part of the treatment zone. Underneath that concrete cap is a gravel plenum. Within that gravel plenum, that's about 2 feet thick, there are a series of horizontal vapor extraction wells. There's 21 of them in there that draw contamination from that gravel area that is graded up from the soil. We also have vertical vapor extraction points, and those are drawn from the system through multi-phase extraction wells, and then we apply a vacuum to some of the electrodes. To remove groundwater from the system, that groundwater, the bulk of that is removed from multi-phase extraction wells. We'll see some of those. They pump groundwater out of the system. And then there also is some amount of water that comes out with the vapor. As that vapor cools, water is drawn out of that vapor and is collected and mixed with the pumped water and treated prior to being discharged. Next slide. All right, so this is looking toward the north at the B&M parking lot. This area where you see all this equipment, that's our process area. That's where the groundwater and the extracted vapors end up to be treated and ultimately discharged. It's also where our steam plant is, where the steam is generated. It sits in B&M Logging's parking lot. And you see North Hamilton Road there off in the upper right-hand corner there. Next slide. All right, so this is then looking to the east from that same vantage point, and it shows the actual thermal treatment zone where the steam is applied and electricity is applied. You see that's in that corridor between the interstate and Hamilton Road. And some of our points even extend into Hamilton Road, as you can see there. So one of our challenges then is to get the materials back and forth across Hamilton Road. And so that's one of the things we've had to overcome are the space constraints of the site. Next slide, please. So this is a picture actually of as we're installing our steam and vapor collection lines underneath Hamilton Road. There's a bit of congestion there in the right of way, as you can see. The next thing we're going to do is we're going to start a little virtual tour. And the way this virtual tour is organized, we'll take a look at the energy inputs first. We'll take a look at the steam plant and how that's distributed throughout the well field. And we'll take a look at how the electricity for the electrodes is distributed. Then we'll kind of take a walk through the actual well field. We'll take a look at the different types of injection and extraction points that are out there. And then we'll follow back both the vapors that are collected and the liquids that are collected, and kind of walk through their treatment processes and how they're removed from the liquid and the vapor. So Dominic, you want to start the video? All right, so we start with our steam plant here, and the inputs into the steam plant are the water, which you see there in front of you, and there's diesel fuel then that runs the boiler that heats up the water to generate the steam. So the boiler sits in the trailer. It's not real exciting. Generates the steam. The steam exits through this steam line. The steam line's insulated and goes underground. A steam line transfers through the trench we just got a peek at. Over to the other side of the road. Dominic, I think the video stopped. So then the steam line comes up out of the manhole and then is split into two different headers. One header goes down each side of the creek. You see there, that's kind of temporary. That is the temporary channel for Berwick Creek. We'll talk about that more later. But that's how the steam is distributed. Then we have the electrical inputs to the system. The utility transformers that pull power actually from the power lines that are right over the site. So we got one transformer that feeds the process area over in B&M logging parking lot. And then this larger transformer feeds the well field. Power goes from the transformers into this power distribution box here that essentially splits that power feed into four different quadrants, four different units. And there's other electrical conditioning equipment in here that I don't know how to describe, so I won't. But once we leave there, I said that's split into four different divisions. So then there's four different transformers out here that we can then control the amount of power that goes out to the well field. And this power then is distributed from these transformers across the creek. Half of the units or so are on the other side of the creek. So the power runs through these big extension cords essentially to these junction boxes here that distribute then to each of the electrodes. And those are on both sides of the creek. So there's a large amount of cable running around that feeds these electrodes. There's a total of 49 wellheads that have electrodes in them. 34 of those are dual, meaning that they have both shallow and deep. So here we'll take a walk further through the well field, take a look at the different types of elements that are out there. So you see there's three main headers that run through here. We have the steam injection header, which is the middle one. It's generally has the white insulation on it. Then we have the vapor extraction line, which is the fiberglass pipe, which is the brown one on top. And here is a steam point. So we've got a steam connection to the steam line, goes to the hose to this steam injection well. And there are controls on there that control both the pressure and the flow of how much steam we're injecting into that particular point. So you see there it's connected to the steam header. So the next point we see here, this will be a multi-phase extraction well. This one with the orange top. And so it both is pumping groundwater out of the ground and sucking vapors out of the ground. So the black line coming off the top, tied to the insulated pipe, that's where the liquids come off. And then the vapors are connected to the fiberglass pipe on top. And there are a number of these. There's 13 of these multi-phase extraction wells throughout the area. So there's a temperature monitoring point, that skinny point there. And there are 16 of those throughout the site. And this here is an electrode. This happens to be a dual electrode. There's two different elements down there, one in the shallow, one in the deep, and then a vapor extraction coming off the top. So we'll take a look at more of these. There's another multi-phase extraction well, another electrode. You see all the connections to the main header pipes that go back to the actual wells. That's a horizontal vapor extraction well that we talked about. There are 21 of those on the site that are pulling vapors out of the ground. And now we jump to the other side of the creek and walking along here, and we have kind of the same types of points as we go along. And everything is, tied back to the main headers and either collected to go back to the treatment area or being distributed out there in the well field and being injected into the ground. So now we'll chase this the vapor phase back and kind of walk through its treatment process briefly. So the vapors come up out of the ground. They're at that white pipe you see there. And they're taken back to the the vapor treatment trailer. Inside that trailer, then we go through a little series of processes. The first one is a condensate knockout tank that removes water from the system. Then these are heat exchangers to remove the heat try and reduce the heat. Another moisture separator, again, trying to pull as much moisture as we can out of that air before it goes through the actual treatment process. Next here, we'll see the blowers, and these are what's creating the vacuum clear out to the well field. It's taking the vacuum and pulling the vapors out of the ground. And then on the discharge side of those blowers, it discharges through our actual treatment process, which are the vapor phase granular activated carbon. And that granular activated carbon collects the PCE and other contaminants in it as we blow the contaminants through 3 different vessels of this granular activated carbon, and the carbon absorbs the PCE. So by the time it goes through those 3 vessels, the PCE is transferred from the vapor phase to the carbon. You see all the mess of hosing there. That's because the lead vessel, of course, fills up first. And so as it's changed out, the carbon is changed out of it, and it then becomes the lag vessel, and what was the middle vessel becomes the lead, and so forth. So those hoses have to be transferred around. So following its passage through there and the collection of all the contaminants out of it, that is discharged to the atmosphere. Now in the liquid phase side, we have a similar type of process. We come up out of the ground there where you see the black insulated pipe. From there, the liquid makes its way to the equalization tank, which is that orange tank there. That's also where any of the liquid condensate from the vapor phase is also transferred to that tank, and they're mixed together at that point. That liquid is pumped from the equalization tank via this set of pumps here, and into this first set of cartridge filters, which removes particulate matter from the water. Then it goes through these heat exchangers to try and cool the water. Following the heat exchangers, we go through an oil water separator. Following the oil water separator, the water is repumped, goes through a second set of cartridge filters. We want to remove as much particulate as possible so that that particulate doesn't plug our activated carbon system, which is here. Again, there are 3 vessels in series. Same technology as for the vapor. There's the third one, in that the PCE is absorbed onto the granular activated carbon. Following the carbon treatment, then it's discharged to the sanitary sewer. And so all the contaminants are captured by the granular activated carbon prior to discharge to the air or to the FTW for treatment. All right. So how are we doing so far? Well, we've operated for about 70 to 75% of our planned operation period. We've applied over 1.25 million kilowatts of electricity to the system. We've injected over 7 million pounds of steam. We've been able to affect the subsurface temperatures throughout the treatment zone to an average of 100 degrees Celsius, basically to boiling, throughout the treatment zone. We've treated 3 million gallons of groundwater. And most importantly, we've been able to remove over 5,000 pounds of PCE from the environment. All right, so got a few little graphics here to show you. Part of our control system is a website that the operators of the plant and the members of the team can access and view live what some of the temperatures are and some of the processes going on in the field. So what you're seeing here on the left is kind of an average temperature plot. I think we saw one of the temperature monitoring points, and as I told you, there's 16 of those. And so that's what these colored circles are. And the colors represent the temperature, essentially, the average temperature at that particular point. Those probes are made up of different temperature elements every 5 feet as you go vertically down from top to bottom. So then the graph on the right is showing the average temperature at each of those points. So if you were to average all of the temperature elements at all of the points, generate that curve that's shown there, and you see that it's up to 100 degrees Celsius now as of the first part of June here. And it started at about 18 degrees Celsius. So a nice gradual warm up of the subsurface. Next. All right, mass removal. So what this is showing, the graph on the left is showing the amount of mass that's been removed from the system in the liquid phase, which is the blue line, the red line is the vapor phase, and then the black line is the total. So you'll see that the vast majority of the contaminant, the PCE that's been removed from the system, has been through the vapor. And you see there that we're up over 5,000 pounds of PCE removed from the system, from the environment. Then the graph on the right is showing the inlet concentration of PCE to those granular activated carbon tubs. So this is the blended vapor after it's been pulled out of the well field, came across the road, and getting ready to go through the treatment system. And so you see, as that was heating up, we started this operation about February 15th or so. And see, there wasn't much happening until you got till about the third week of March or so, when the temperature finally got up to around 80 degrees or so. 80 degrees is a critical temperature where the PCE starts to come out of liquid into the vapor phase. And so you see then we had a good strong surge upward in those concentrations. We peaked and we are on our way back down. Things seem to be going pretty close. You know, if you recall, we said we're about maybe 75% down to the planned treatment time. So it appears that things are pretty much on schedule to get done as planned. Next slide. All right. Now we're going to shift a little bit from the ISTR system itself, to kind of part of what went into this. As this project has been under development for the last several years, you know, one of the main objectives of the project, you know, for the Corps and the EPA has been how to get this contamination cleaned up without adversely impacting Berwick Creek and the wildlife associated with it. And so that's been of utmost concern to everybody during the planning and the design and the implementation of this. So I wanted to kind of touch on this for a little bit. One of the things that we needed to do here was to remove contaminated sediments from the creek. And so we accomplished that. Next slide. Then we needed to be sure that we insulated that channel because as we've seen, you know, we've got boiling temperatures all around it, surrounding the creek. And so it was important to get that insulated so that we don't adversely impact the temperature of the water in the creek. So what you see there in that top photo, if you can see it, is there's insulation that goes all the way around this temporary channel we installed. So there's 2 3-inch thick layers of rigid foam that are laid down there in the bottom. On top of that foam, then we've got an HDPE liner that was laid down. And then we set this channel. It's called Mega Ditch, is the product that it is. It's a trapezoidal channel made out of HDPE. After we had that installed on top of the rigid foam board, then we also have 6 inches rigid foam board that we put along the sides on both sides. And then that, again, that's all wrapped in the HDPE liner. That HDPE liner prevents the migration of water or vapor either in or out of the creek. Next. All right, another element of the protection of the creek is to provide a means for fish passage. And as you may have noticed in some of the walk around slides, the water level is quite low now. And you're aware, living out there, it's been really dry this spring. And you know, if we just would have put a flat bottom channel in, there may not have been enough water to allow fish passage. So we put in this half pipe, which provides a low flow way, a way to concentrate the water. So even though there's not much water in the ditch, there's a foot of water in that channel that allows for the passage of fish or any kind of wildlife that wants to go through there. All right, and The other part of the protection then, of course, is water quality monitoring. So we have water quality monitoring points. We have one upstream of our work. We have one right in that mega ditch channel. And then there are 4 more as you go downstream. At those water quality monitoring, they monitor temperature is what all of those do. But in addition to just monitoring temperature at all those points, we also monitor pH, turbidity, and something else. Can't remember right offhand. But so we're monitoring the water quality there to verify that what we're doing is not impacting the water quality. So next. All right, we're gonna watch a little video here. This is pretty short, just kind of showing the creek itself. So this is looking at the upstream end of the channel. So this is a little bit disturbed up here. We had to go 100 feet beyond the thermal treatment zone to remove some of the contaminated sediments. So that has been done. And so then here, as we take that natural channel and transition it into the mega ditch, that's done here with this transition piece. And then you see the water flowing down the channel, and that's a crawdad that is actually in the half pipe. Was swimming around. It stopped there. And our guys do see fish in this channel, not large ones that I know of, but some of the smaller ones. This is one of our monitoring stations. See the element that goes down there into the half pipe is monitoring level and temperature. And then that float switch is part of our operations to give us an idea of when the creek level is rising and to make sure that we're aware of what's going on from that standpoint. We transition back then to the natural channel here. And as Linda had said, once we get done with all this, the creek will be restored back essentially to the way it was. All right. I want to talk a little bit about safety considerations. Again, I'd mentioned a little bit earlier that we do have a data website that we can monitor, the operators can monitor, and the rest of our project team can monitor. There are also automated alarms that are more dedicated to the treatment system and things that are beyond what I need to know about, but they do automatically dial out to the operators of the system, and they're on call, 24 hours a day, 7 days a week to address any alarms. We have fencing up and no trespassing signs, video cameras, motion detectors, all kinds of precautions to keep people out of there or to let us know and shut things off if somebody or something does get in that well field. As the electricity is being applied in there, our own operators can't even go in that area just for the risk from the electricity. So it's very important to stay out of there, and we do everything we can to keep people and things out of there. Another safety precaution is the congestion for traffic. As you noticed, or if you've driven through there, we've taken some of the shoulder space. We've got barricades up on the side, and we've got the distractions of just people wanting to look at what's going on. So it's just a reminder for everybody to be cautious driving through there. We do, as pedestrians, have to cross back and forth several times a day. So everybody just is on their toes and trying to be cautious of that. We also do perimeter air monitoring where we daily, where we go out and we have a round of locations that we check upwind, downwind, within the treatment zone, within the process area, just to verify that we don't have any contaminated vapors escaping the system. And in addition to that, as Linda mentioned also, this was all done during the strictest part of the COVID requirements. And so all of our contractors and subcontractors were required to follow all the state COVID rules. And fortunately, everything worked out just fine that way. So with that, Andy, I'll turn it back to you.
Hey, thank you, Michael. That was great. We do have some interesting questions coming up for you, Michael, in the chat box. I'm going to hold off on those for just one more minute, because before we do that, I'd like to give a moment for Lee First, the Twin Harbors Waterkeeper, to say hello to all of you. Lee, get your camera on and say hello if you'd like.
Thank you, Andrea. Hi, everybody. My name is Lee First. I'm your Twin Harbors Waterkeeper. I'm based in the Lower Harbor in rural Grays Harbor County. And as your waterkeeper, I advocate for fishable, drinkable, swimmable water in the Chehalis and Willapa Bay watersheds. Twin Harbors Waterkeeper is a recipient of a Washington State Department of Ecology public participation grant. And through that grant, we've been working on outreach and education to people in these watersheds about Washington State toxic cleanup sites in the Chehalis watershed. And because this site is in our watershed, we have been working to help raise awareness about the great cleanup work being done here by the EPA and their contractors. We applaud these efforts, and we hope that more people will become interested in cleanups in the lower basin. And if you would like to know more about sites in the lower basin, I would love to hear from you. And I'll put my name and the website for Twin Harbors Waterkeeper and my email in the chat. And thank you so much for attending today.
Thank you, Lee. It's great to have you with us, and it's been great to coordinate with you on this project. So we are ready now to take some questions. We have several questions that have come up in the chat, but I'd like to first invite the folks from the phone, if you have a question, to please go ahead and speak up. And I'm going to take one or two from the phone, and then we'll move back to the chat, and we'll take as many questions as we're able to until we are up against the top of the hour. So is there anyone on the phone who has a question? Okay, hearing none, I'm going to move then to the chat. And Michael, I know we've got some questions here for you. Let me pull them up here. Incidentally, I have added some links to the chat that may be of interest to you, and I can talk about those in just a moment. So, Michael, why does the stream have so much sediment?
Well, I'm not sure which picture you're looking at. If it's the one with the high flow, that was due, I guess, to the high flow. That picture was taken shortly after the snowfall in February, as that snow melt was happening. And what you were looking at was the upgradient side, and it's just the natural sediment that's in the creek, whether we were there or not.
Okay, thank you. LE asks, how many gallons of water are being heated up? And also, Michael, are those headers insulated?
All right. I don't have a good answer for you on the volume of water. I don't know if anybody else does. You saw the area of the treatment zone. I know that we have calculated the volumes of soil that are being treated. I don't have those numbers in front of me either. We can get those to you if you really need them or want them. As far as insulated, yes, the water lines are insulated, not necessarily to keep the heat in, but to keep them from freezing in the winter. Because again, this system, we started moving water through this system at the first part of February, doing some of the testing and such. And there was opportunity for freezing. So the water line was insulated. The steam line is insulated because we're generating that heat, and we want to get that heat to the subsurface without losing too much of it. And then the vapor line, that was the fiberglass line, and that is not insulated.
Okay, thank you. Michael, LE also asks, what percentage of PCE is removed?
From the vapors and the liquid, it's nearly 100%. By the time it's done, going through this, for example, for the vapor, so you saw that we have extracted almost 5,000 pounds of PCE in the vapor. We have discharged less than 1 pound to the atmosphere. The rest of it has been absorbed onto the carbon. On the water side, again, that is like 99.9% removal by the time it goes through by the time it goes through all the layers of carbon.
Those are some impressive numbers. Michael, are there automatic sensors in place for air quality?
There are not automatic sensors. I don't know if you're talking about the stack discharge or just the general air quality, but the general air quality, like I showed or talked about, is monitored every day with that PID to make sure that the area within the treatment area and outside the treatment zone, the vapors are safe. And then we take daily readings with a PID through the carbon units as well. And then those are confirmed with a monthly sample that actually goes to the laboratory and is analyzed. And that's how we calculate the pound of contaminant that are actually discharged to atmosphere. And our discharge limits to atmosphere, we're nowhere near what those are. So for example, it's based on each contaminant, but it's this one. More of the stricter ones are TCE, which we don't have very much. That has 5 pounds a year. PCE, which we do have, that is in the 200s. It's 247 or something pounds per year that we would be allowed to discharge. And again, all of our contaminants combined have been to date 0.8 of a pound. So we're well within our limits.
Fabulous. Okay, once again, I'd like to invite anyone on the phone who might have a question to go ahead and speak up. All right. Devin has a question. Has monitoring occurred downstream of the site during the ongoing operations? Will any further action be required once the cleanup at the current site is completed? So, Linda, let me pass that one to you and you can answer that second question first. Will any further action be required once the cleanup at the current site is completed?
Yeah, so for this piece of the project is to address the source, and we have monitoring down gradient of the source to make sure our removal action and this work is effective. So we'll monitor the groundwater really close in to the source near B&M Logging's shop. And then we know that there was additional sources in the livestock market area and down gradient, but we didn't really initially know how much was from the livestock and how much was from this. So after we see the effects of our treatment and this piece of the remedy, we'll do more investigation and see what further work needs to be done in that offsite location. So there will be more work, yes.
Thank you, Linda. Also, Linda, do you have an estimated date of when the chemicals were originally dumped?
Yeah, I put that in. It was around 1990. I think that was when the initial source was found.
Okay, thank you. And Michael, back to you. Lee is asking, what happens to the condensate? Is it treated? How?
All right, so the condensate that's collected out of the vapor stream, that is combined with the groundwater that's extracted from the treatment zone. So if you may recall that red equalization tank that we talked about in the liquid phase treatment, any condensate that's collected in the vapor trailer gets pumped over to that equalization tank and is combined with the other groundwater.
Okay. So I see that the questions in the chat have either been answered by you, Michael, or by Linda, and or typed in response right here in the chat box. We do have another question coming in. How expensive is this to set up and operate? Linda.
Yeah, this project is $14 million.
Thank you. Okay, another question here from Sue. How soon after the introduction of the contaminants was it discovered and responded to? Linda.
You know, Sue Kennedy, are you on the line? The county health department actually notified or was alerted to the contamination in the drinking water in the area at a county fair. And I don't know the exact date, but it was the late 1980s. And as soon as we were aware of the situation that the drinking water wells in the area were contaminated, we provided as an emergency response action, water service, city water service. I don't know the amount of time that lapsed between those two things.
Okay. Marcia notes that the groundwater plume was already well developed by the late 1990s, so I think the disposal must have been quite a bit earlier. Linda, do you want to add anything to that?
Yeah, no, I haven't dug into the history, so I really don't have accurate dates, so.
Okay. Is the cleanup being paid for by the liable party or by federal funds, Linda?
So this source, this disposal, we could never track down. EPA did a lot of criminal and civil investigation, and we were not able to tie this source of contamination back to any specific person. So this is a federal cleanup project.
Okay, and Sue responded to the earlier conversation there that it was the mid-1990s was when it was discovered and investigated. Thank you, Sue. All right, again, back to the telephone lines. If anyone of you has a question, you're welcome to speak up and ask your question now.
Hello, Andy. This is Mike.
Yes.
And I did a little research while I was sitting here, and I did not find the volume of water that we're treating, but I did find the volume of soil that's in the thermal treatment zone. And that is about 12,000 cubic yards of soil. Most of that is saturated, meaning that it contains water. So that's the best I can do as far as the amount of water.
Okay, thank you so much. Dominic is adding that the release is estimated to have occurred between 1974, when the road was constructed, and the early 1990s, when PCE was detected in the groundwater. Thank you, Dominic. Okay, any additional questions for the chat? I'll just point out here that we have entered a few resources for you in the chat box in case you'd like to do a little bit more learning about the site. We have a video about the history of the site and the cleanup on YouTube, and you can find the link here in the chat. Our EPA Hamilton Labree website has a lot of information, including background, documents, history, and current activities at the site. So we invite you to visit our website at epa.gov. And a fact sheet, the most recent fact sheet, kind of brings you up to speed on what we're doing there and kind of lays it out in more simple terms. So if you'd like to look at that, there's a link here in the chat box for that as well. For those of you on the phone, we invite you to come to the EPA Hamilton Labree website, which is at www.epa.gov/superfund/Hamilton-Labree. And of course, you're welcome to call either Linda Meyer at 206-553-6636 or me, Andrea Lindsay, at 206-553-1896. And give us a call anytime. We're happy to chat with you and answer any questions. I would like to just say thank you one more time for all of you for being here with us today. It's great to see the interest, and we really appreciate you taking time out of your busy day to spend a little time with us and learn about our treatment plant. Thank you so much for coming.